Hey everybody. I hope y'all are staying warm, staying safe. Sitting here on my couch with a fire in our fireplace. So this is the way to do class. We should do this more often. But anyways, if you can hear that, that's what that noise is. But we're gonna pick up in chapter 5, and this video is probably gonna be pretty short. I'm going to talk about the second type of chemical reaction. I want to remind you, though, before I actually tell you what that is, where we left off in class. We last talked about precipitation reactions, and I introduced these solubility rules. So precipitation reactions, remember, they produce some sort of solid, okay, some compound that comes out of solution, and it's denoted with an S on the product side. It's insoluble, and we talked about these solubility rules, and we did an example problem. And I'm going to skip over this problem because I'm really trying to just get to number 2, the second common type of chemical reactions, which is going to be an acid-base neutralization reaction. Acid-base neutralization reaction. Okay, so just reading this name, what this is going to mean is that we have some kind of acid reacting with a base, and when an acid and base react, they produce products that are neutral, and I'll explain why in a minute. I'm going to read this definition, this bullet point underneath, and then I'm going to also, after I explain a few things, give you a more broad definition, okay? So this says an acid-base reaction commonly, and I really want to emphasize this word for a second, commonly, which means this is not the only way to define an acid-base reaction. And that's just kind of the nature of chemistry, is there's so many different types of matter and ways and reactions that occur between those matters that we can't always come up with a perfect definition to encompass everything. So commonly, but not always, an acid-base reaction will occur between an acid, and we're going to represent an acid as HA, okay, because acids always have hydrogen in them, okay? The very definition of an acid, there's probably multiple ways to define what an acid is, but it has a hydrogen, and they donate that hydrogen to the base, okay? So here we're saying it's going to be between an acid, HA, and a metal hydroxide, which we will abbreviate as M with OH, M standing for metal, OH obviously is hydroxide. It says to yield water and a salt. Okay, so you have a generalized reaction just underneath. Here's your acid. It is aqueous, and here is your metal hydroxide. This is your base in this case. It is also aqueous, and what's going to happen is this hydrogen right here is going to be broken apart from the acid. So we say the acid dissociates into the hydrogen and then the anion portion, because hydrogen is positively charged, and the anion portion, whatever it may be, chloride or bromide, or it could be a lot of different things. So it's going to be dissociated, the hydrogen will be dissociated from the anion portion, and it will be donated over here to, let me highlight the hydroxide, okay? So it's going to be donated over here to the hydroxide. All right, and obviously when those things come together, guess what? They make water. OH plus H gives you H2O. And then what's left over, I guess I could highlight in a different color, is going to be the anion portion from the acid, and the metal, which is going to be the cation portion from the base, because we know hydroxide is negatively charged. Metal here would be positively charged. These are going to make the salt over here, which is just what you see as Ma. Metal is the cation, A is the anion from the acid. All right? So this is one common way to define an acid-base neutralization reaction. But the other, I guess, a way we could expand this definition is an acid-base reaction is one, let me write this, acid-base reaction. Let me zoom in on this, is one in which a hydrogen is transferred from acid to base. Okay, it's just a reaction where hydrogen is being transferred, and in doing so, it neutralizes the acid and the base. We find, obviously, commonly that acids have very corrosive properties to them. Bases can also be dangerous at high concentrations, and when these reactions happen and the neutralization occurs, you're creating these very non-dangerous products, okay, safe products. So this is I'm going to put a star by that, as that's more of a general way to define acid-base. We'll really dig into that in chapter 10, but I just am giving one specific example here with the acid and metal hydroxide. Is a very common type of acid-base reaction. So just know both of those definitions for exam 2. And I think you'll be fine with that. And then I have a few tips here. So this probably kind of explains what I walked through and did all the highlighting and color coding. It just says tip, the hydrogen ion, which is what I highlighted in pink, from the acid combines with the hydroxide ion from the base, and that's what gives you the neutral water, H2O. Then the anion from the acid, which is left over once the hydrogen leaves, the anion portion from the acid will combine with the metal from the, I should just say cation. In our example, it was a metal, okay? But cation from the base to give the salt, okay? So here is another example down below. This is acetic acid. It's the acid in vinegar. Later in the semester, we'll actually do a reaction with these two products right here. Acetic acid, we'll use vinegar, and then strong sodium hydroxide will be our base. Okay, so acetic acid, and then this is our base, sodium hydroxide. And the red portions are going to combine together, and the black portions are going to combine together. So here you see this is the hydrogen, the acidic hydrogen. I know there's other hydrogens in acetic acid, but this one is the one that's acidic and will be donated to the base. Okay, and that's going to make, I guess I should write it in black, shouldn't I? It's going to make water. And then when the red portions combine, it'll be plus sodium acetate. I'm just going to write it CH3CO2. Same thing as CH3COO. All right. So we have a practice problem now. So I would love for you to pause this video and try to write this equation, and then once you think you've got it, you can pick up with the video and check your answer. Okay, so try to do that before you just watch me do it. All right, assuming hopefully that you've done that, what this says is you've got cesium hydroxide and hydrogen sulfate. So cesium is CS, and it is main group 1, so it is going to have a +1 on it as the cation, and hydroxide obviously is OH minus. And then you've got hydrogen sulfate, react to yield what? Well, if it's acid base, well, let me write our other thing first. Hydrogen sulfate, H2, because sulfate is got a negative charge on it, and so H2SO4. All right, so let's put all these together. So we're going to have CSOH. This is our base, cesium being the metal, OH being the hydroxide, metal hydroxide. So this one is our base. And then we're going to have plus H2SO4. This one is the acid. All right, now you might be looking at these being like, how am I going to know which one's the acid and which one's the base? They both have hydrogen in them. Well, specifically, if you're thinking of, if you know what a metal hydroxide is, that's one way you could determine it. Not all bases have hydrogen in them. This one happens to because of the hydroxide, but again, hydroxide's not always the base. So usually the one that has hydrogen in it, I say usually, not always. But anyways, I've defined these for you, so it's really not, I'm not going to be asking you to identify which one's the acid and which one's the base on the exam. But I might ask you, I will ask you to identify an acid-base reaction. But anyways, let's keep going. So we know that the hydroxide, okay, and the hydrogen from H2SO4 are going to combine, all right? Now, only one hydrogen can go at a time, because hydroxide can only accept one hydrogen, okay? So only one hydrogen at a time. And you might notice here that there are 2 hydrogens in H2SO4. So we would need more than one molecule or compound of cesium hydroxide, all right? So we're going to write the full complete reaction, H2SO4, and we're going to think of this, oh, what am I writing? I just meant to write H2O, H2O. And we're gonna write it as though both hydrogens are ultimately going to be donated from H2SO4, all right? So the other compound that we're going to get is just going to be between cesium and sulfate. All right. Now, you might recognize, I want to make a point here, what kind of reaction is this besides acid-base neutralization? It might help you if you recognize, is this a combination reaction? Is it decomposition? Is it single displacement, double displacement, or combustion? If you could recognize it's actually also one of those 5 that we have talked about in a previous lecture, that might help you predict the products here. And so we have 2 aqueous ionic compounds, and this is double displacement, okay, where the cations and the anions ultimately switch. And that might also help you write these products out if you remember the rules for double displacement from class. All right, so we're going to write CS, and remember cesium is a +1 over here. Sulfate we know is SO4 with a -2. So we're combining a cation with a +1 and an anion with a -2, so we're going to need 2 cations. So it's got to be CS2 and then SO4. Okay, and now we would need to balance this. I don't give you those instructions here, but you always want to make sure things are balanced when you're done. So I've got 2 cesiums. So I'm going to come back and put 2 in front of cesium hydroxide, and then I'm going to need to put a 2 in front of water as well. And I think that's good. 4 hydrogens, 2 oxygens, 4 hydrogens, 2 oxygens. So, yeah. So that's the way you would write out that one. If you have any questions on these, again, since this is video and we're not in class together, write your questions down as you go, and send me an email or plan time within the next week to come to my office hours or schedule an appointment with me, and I'm happy to answer those questions if you had one come up during this video. So I'm going to end this video, and then in the next one we're going to hit up the last way to classify chemical reactions, which are redox reactions.